Hi Algebra 2 students, welcome to the second video for Chapter 10. Today we are going to be talking about permutations and factorials while also still building on what we learned in the last video about the fundamental counting principle. So to start with some definitions here, some vocab, we've got permutation, and a permutation means an ordering of objects. So let's say we wanted to figure out how many ways we could order the letters ABC. Well, we could do ABC, ACB, BAC, BCA, CAB, or CBA. So if you count, that's 6 different ways that we could order that, or we could say 6 permutations. Another definition would be factorial. So the way that we represent a factorial is with what looks like an exclamation point. So to just demonstrate what we mean when we say factorial, if we've got 4 factorial, that means that we start with 4 and we multiply by all of the numbers smaller than 4 and then ending at 1. So that would be like 4 times 3 times 2 times 1, which gives me 24. Well, let's say we also had 6 factorial. Well, that's very similar. We've got 6 times 5 times 4 times 3 times 2 times 1, which we could go ahead and type that in our calculator, giving us 720. But we could also use our calculator. We have a factorial button. So if you look over here, I have the calculator steps for you. So first, you want to click your number. We want to figure out 6 factorial. And to find the factorial, you go to Math, which is right there. Then use your arrow to go over to highlight at the very top. We're highlighted in Math right now. You want to go and highlight the PRB probability. And if you look, it's the 4th one down right there. Okay, so then we click Enter and 720, which is what we got before. All right, so let's look at some examples. So the first one here says 8 teams are competing in a baseball playoff. So that's important. We've got 8 teams. And how many different ways can the baseball teams finish the competition? So if you look here, I already kind of started part A. We want to know in how many ways can they finish between first place all the way to 8th place. So for first place, let's say we had to choose it. Well, we've got 8 teams to pick from. But now we've already picked somebody for first. So for second place, then we'd have 7 teams, and then 6 teams, and then 5 teams, and so on here. So that is the same thing as 8 factorial. Now we could just type in 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in our calculator, or I can click 8, go to the Math button, over to the probability, click the 4, and our answer would be 40,320. Okay, and then for part B, well, this one just wants to know in how many different ways can 3 of the baseball teams finish first, second, and third. So for first place, we have 8 teams to choose from, then 7 teams, then 6 teams, but that's it. We don't continue. So I'm just going to take 8 times 7 times 6 in my calculator, and we get 336. Okay, so the next piece that we are going to talk about is permutations of n objects taken r at a time. So we have this formula here, but we use like a different notation, especially within our calculator. So this is our formula, n factorial over n minus r factorial. But this is the notation that we use the most often, especially with our calculators. N is our group, and that's the number of things to choose from. Okay. And R is how many that we're going to choose. So let's say I had 8 groups and I was going to choose 3 of them. Well, that's the same thing as we've got 1, 2, 3 times 8 times 7 times 6. But in our calculator, so this is important here, we're going to go back to the math function, over to probability, and I believe it's the second one down, and you'll see an NPR. Okay, so let's do that, 8P3. So 8, click the math button, over to probability, and yep, it's the second one down, and then I'll click 3. So our answer here is 336. All right, so now let's look at the guided practice here. So I wrote the calculator steps again. This problem here is the same thing as saying, so we've got 5 groups and we want to choose 3 of them. So we could do 5 times 4 times 3. But in the calculator, we could click 5, math, go over to probability, the second one down, 3, giving me 60. Okay, so what you should do is go ahead and pause the video and try 5, 6, and 7 and make sure that you get the same answers that I have written down here, just to make sure you know how to type it in. Okay, and let's go to the next one here. So example 4, we're going to find permutations of n objects taken r at a time. So you have 6 homework assignments to complete over the weekend. However, you only have time to complete 4 of them on Saturday. In how many orders can you complete 4 of the assignments? So there's really 2 ways we can think about this. We could think about it with the fundamental counting principle or as a permutation. So first for n, well, how many groups do we have? Well, it looks like we've got 6 homework assignments to choose from, okay? And we want to choose 4 of them. So R is going to be 4. So for the fundamental counting principle, well, we could say, okay, well, you know, I've got only 4 assignments that I can choose from. And I've got 6 I could choose from for the first one, then 5 to choose from, then 4, then 3. So you could solve it like that. And in your calculator, go ahead, take 6 times 5 times 4 times 3, which gives me 360. Okay, but we could also think of this as a permutation. We've got 6 groups and we're going to choose 4 of them. So in our calculator, 6, go over to probability, the second one down, 4, and that's also 360. All right, if you'd like, go ahead and try example 5 on your own. Otherwise, we're going to do this one together as well. So your Algebra 2 class is voting on who's the best dresser, dancer, and best athlete. If no person will win more than 1 award, how many different ways can the awards be handed out? So we could think about this again as a fundamental counting principle or a permutation. But something that we're missing with this problem is, well, we know we've got 3 things to choose from, dresser, dancer, or athlete. But how many students are in the class? So I think for this one, we actually need to come up with our own number. So let's just say that there's 30 students in the class. So we've got a best dresser award, a best dancer award, and athlete. So we would have 30 to choose from for the first award, 29 to choose from, and then 28. So 30 times 29 times 28, and that gives me 24,360 ways here. And if we want to think about it here, so we've got 30 and we want to choose 3 as a permutation. So that also gives me 24,360. Okay, last part that we're going to talk about today is permutations with repetition. So that's the number of distinguishable permutations of n objects where one object is repeated and another is repeated, and so on and so on. So it wants us to find the number of distinguishable permutations of the letters in even and in California. So there is kind of a formula up here, but I'll just talk you through it a little bit. So let's think about the word even. So what we're going to do is you figure out, okay, well, how many letters are there? So I count 1, 2, 3, 4 letters. So you write down your total. And then how many are repeated? So notice we have an E here, but we also have an E there. Put that a little smaller. We have an E and an E. So I'm going to write 2 E's. So the way that we set this up is I'm going to put 4 for 4 letters, and then I'm going to put the factorial, and then that's over 2 factorial for how many are repeated. So you can use your calculator for that, or you could think about it as 4 times 3 times 2 times 1 all over 2 times 1, which would give you, those cancel there, so this would end up being 4 times 3, which is 12. But you could type it in, 4 factorial divided by 2 factorial which is 12. Okay, so then for California, so we want to think about, okay, well, how many letters are there? So if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we've got 10 letters. So we know we're going to have 10 factorial over something. And now let's think about how many are repeated. So I think I see here we've got 2 A's. And what else do we have? It looks like 2 I's. Oops, wrong one. All right, so I'm going to write down 2 A's and 2 I's. So I'm going to put this in parentheses because there's 2 of them this time, like this. So over 2 factorial times 2 factorial. And again, you could write it out like I did the last one, or you can use your calculator. So 10 factorial divided by, and use your parentheses. All right, and that gives me 907,200. Okay, so let's just look at a couple more here. This is a checkpoint. If you want to pause the video and see if you can do this, go ahead. Otherwise, we can look at it together really quick. So it says find the number of distinguishable permutations of the letters in. So let's look at TAM first. So notice there are 3 letters and no repeats. So this here would just be 3 factorial, which is 3 times 2 times 1, so 6. For V, there are 3 letters and there's 2 E's. So we've got 3 factorial over 2 factorial, and you could solve that out if you would like to, using your calculator just to practice. And that would be 3. And then Carl Carlson. So let's count the letters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I count 11 letters. And I see 2 C's, 2 A's, 2 R's, and 2 L's. So we will have 11 factorial over 2 factorial times 2 factorial times 2 factorial times 2 factorial. You do want to use your calculator for that. You guys go ahead and try that one, and it would give you 2,494,800. All right. So that's the end for this video, and I will meet you guys in part 3. Thanks.